Welcome to the deep dive. Today, we're looking into something pretty fascinating. How can we, fundamentally change learning, make it faster, deeper, more captivating? Because let's face it, traditional education, well, it has its place, but often it feels like you're just absorbing things passively. Or maybe not even absorbing, just disengaged.
That's such a key point. Conventional approaches, heavy on lectures, maybe rote memorization, relying completely on the teacher, they often just miss how our brains actually learn best. And that disconnect, it leads straight to students tuning out and, well, not retaining much in the long run. It's often the system, not the student.
Exactly, and that sets the stage for what we're exploring today, this Taxshila Teachers Model. We're
Yeah.
basing our deep dive on some really interesting new research. It's called Universal Learning Transfer, Scaling the Model of Taxshila Teachers by Shivanarayan Taxshila Page, just published June 13th, 2025. So our mission today is to really get under the hood of this. How does it redefine roles in the classroom? How does it tap into neuroscience? And crucially, how does it put students
Uh-huh.
in the driver's seat for knowledge transfer? Okay, let's jump right in then. This Taxshila model, it has this, well, it sounds pretty radical, this idea of students becoming small teachers. What does that actually mean, like in a real classroom?
It is a big shift, absolutely. These small teachers, they aren't defined by how old they are or, some teaching certificate. Instead, they're high-achieving students who've gone through specific pre-training, and they become absolutely central to transferring knowledge, running the classroom day to day, even achieving goals together. Their role comes from demonstrated learning achievement, and leadership in something the research calls brainpage performance.
Brainpage performance. Okay, what's that exactly?
Think of it as not just knowing facts, but being able to actively structure that knowledge, synthesize it, apply it, like building a really functional, accessible map in your head. The paper actually describes these students as trained warriors, skilled with source materials, great at solving complex, sort of modular problems. And the long view, they become this smart workforce, genuinely ready for real-world challenges by, remarkably, age 20.
Wow. Okay. So it's way more than just like peer tutoring. This sounds like a fundamental reorganization of how learning even happens, how knowledge gets in. But practically speaking,
Mm.
how do you keep a classroom productive if the main teacher isn't, well, teaching directly all the time? Are there risks with students taking on so much leadership?
That's a fair question, and it's something the model builds in mechanisms for. Responsibility, peer accountability. It's part of the structure. We can talk more about the traditional teacher's new role in a bit. But the core idea here is shifting from passive reception to active construction of knowledge.
Right, active. And the paper uses some really interesting terms here. Learnography and brain page theory. Can you break those down? How does the brain actually function in this system?
Sure. So learnography, think of that as the whole system, the framework that prioritizes knowledge transfer through these trained students. And at the heart of learnography is brain page theory. That's the active process, you see, where students encode knowledge right into their brain circuits. How? By rehearsing tasks, solving problems, really engaging with these modular source books. The classroom itself transforms, becomes a brain page lab, an environment specifically geared for this kind of structured, brain-friendly knowledge transfer.
A brain page lab. I like that. So why? Why is this brain-based way meant to be better than just, listening and taking notes? What's the underlying science making it work?
Well, what's really fascinating is how it engages our motor circuits along with memory systems. Think about learning a skill, right? Like playing guitar or maybe learning to code. You don't just read about it, you do it. Your motor cortex, basal ganglia, cerebellum, these parts of your brain light up because you're physically or mentally performing the task. This model basically applies that learning by doing principle to academics.
Oh, okay. So it's not just hands-on for shop class, it's hands-on for everything.
In a sense, yes. By engaging in peer-led sharing, task performance, students are using more of the brain's machinery to literally wire in the knowledge. It gets around the limits of just listening passively or memorizing facts, which often, well, they neglect these crucial neural pathways. It leads to deeper, more active, and frankly, stickier learning.
That makes sense. A huge difference from just sitting through a lecture. So how does this look in the classroom itself? You mentioned restructuring. Talk about these miniature schools.
Right, so within this Taxila framework, the larger classroom is broken down into these miniature schools. These are basically small, collaborative groups of peers. They're designed for self-directed learning, tackling tasks in modules. And importantly, they're led by those small teachers. This setup naturally fosters leadership, a sense of responsibility, and constant correction and feedback among peers.
Okay, so learning becomes a team sport.
You
almost.
could say that. And this is where motor science really comes into play again. It's that involvement of the motor cortex, basal ganglia, cerebellum, the parts involved in action and skill in academic task-based learning. This accelerates what the paper calls brain page development. That's the deep internalization of the content. And the really cool outcome, it significantly cuts down the need for traditional homework or long verbal explanations because the learning is happening so effectively during the active class time.
Less homework burden sounds like a win. So students are doing so much leading and learning. What happens to the traditional teacher? Do they just disappear, or does their role change completely?
Oh, they absolutely have a critical role, but it transforms, definitely. They shift from being the main source of information to becoming learnography facilitators,
Yeah.
more like expert coaches or guides on the side, you could say. They moderate the whole system. They assess the brain page modules students create, and this is key. They mentor the Taxshila teachers, helping them develop their leadership skills. So their focus moves away from direct instruction towards supervising this brain-based learning environment. It actually reduces the reliance on them needing to teach everything directly.
A facilitator, a
Yeah.
mentor? That's a really different skill set. Okay, stepping back then, what's the big promise here? The paper mentions this ultimate goal, universal learning transfer. What is that, and what are the actual tangible benefits we're supposed to see?
Right, universal learning transfer.
Yeah.
It's more than just applying a math formula to a new problem. It's about building a kind of foundational
Yeah.
mental operating system where new knowledge integrates almost automatically and becomes genuinely actionable, way beyond just recalling facts. The paper defines it as the seamless, scalable, standardized application of learning across subjects, grades, even cultures, all driven by these brain-based methods and modular knowledge. And to understand the how, the research highlights 5 merits of Taxshila teachers. These really capture their capabilities.
Oh, wait, what are they?
First, they're small teachers. Leadership comes from achievement, not age. That really shifts the dynamic, makes learning peer-driven. Second, trained warriors. They're skilled with source materials, adept at modular problem solving, active learners. Third, professional skills. They're not just learning academics. They're developing soft skills, cognitive control things crucial for any career. Fourth, quality coding. This one's interesting. Think of them as becoming expert content creators for their peers. They format knowledge into these super organized, digestible brain page modules, almost like building mini textbooks in their heads that help others grasp complex stuff easily. And fifth, they become a smart workforce, genuinely ready for productivity and complex problem solving by age 20.
That's quite a list. What about the overall outcomes? What does the research claim this model achieves?
Well, the list of findings is pretty extensive. Things like enhanced peer-led knowledge transfer, obviously, significantly better retention and performance because of the brain page theory in action, fostered leadership and responsibility in those miniature schools, deeply active learning driven by motor science. Also, interestingly, reduced classroom stress and disruption, better self-directed learning skills. And then there's the really big claim. Students potentially completing K-Master's level education, basically, the knowledge and application skills equivalent to a master's degree by age 20.
Whoa, hold on. K-Masters by 20, that's ambitious. What's the evidence for that? And you mentioned reduced bullying, too. How does that fit in?
Yeah, the K-Master's claim is definitely bold. The paper suggests the evidence lies in rigorous assessment of brain pace development, showing deep understanding and consistent application across complex tasks, far exceeding typical age benchmarks. As for bullying, the idea, or hypothesis rather, is that the miniature school structure fosters such a strong sense of community, shared goals, and peer support, that students become more invested in everyone's success. It builds mutual respect, leadership from within, which naturally pushes out negative behaviors like bullying. It's about the culture it creates.
Okay, that makes some sense, fostering community. But still, this whole model feels so different. Can it really work everywhere? Can you just scale this up across, say, different countries, different school systems? Or does it need perfect conditions?
The research argues it's actually highly adaptable and scalable. Why? Because it's tapping into universal brain mechanics, not relying on specific, rigid external factors that might vary culturally. The paper lays out some key steps for scaling, a kind of blueprint. First is miniature school formation, dividing classrooms into those collaborative units. That needs teacher buy-in and training, of course. Then, pre-training programs. Really structured modules to get high performers ready to be Taxshila teachers, focusing on task solving, mapping knowledge, formatting those modules. That's an upfront investment.
Right, training the trainers, essentially.
Exactly. Then there's classroom design and technology integration, setting up brain page labs using things like book-to-brain learning interfaces. But the key point here is technology assists. It doesn't replace the core motor and cognitive engagement. It supports the brain-based process. Then teacher transformation. Educators needing professional development to become those learnography guides, those assessors. That's a big shift. And finally, transfer books alignment. Using modular materials like matrix and spectrum books designed for students to build knowledge actively, iteratively, not just passively read. And the paper even details specific dimensions of knowledge transfer that these student teachers master. Things like block solver, breaking down complex problems, or definition spectrum, understanding nuances. It's very granular about how they learn to transfer knowledge effectively.
It's really a comprehensive vision. We've covered a lot, from small teachers to brainpage labs to redefining the educator's role. It really is a profound shift, isn't it? Moving away from just passive listening towards this active, brain-based, student-driven learning. It feels like it tackles those core issues, disengagement, surface learning head-on, while aiming to build a truly future-ready workforce.
Absolutely. And imagine just for a moment what the paper calls a Guyan-Peath space, a learning environment where every single child gets the chance to lead, to teach, to really flourish, where every brain page classroom becomes potentially a launchpad for genius. So maybe the question to leave you, the listener, with is this. What if learning could genuinely be faster, deeper, and just more meaningful for everyone? And what if that could happen for most people well before age 20? It's a powerful idea, transforming education by understanding the brain better and, well, trusting students to lead the way.